Hello, everyone, and welcome to the AWS OnAir Data Dive. We're talking today about Amazon Neptune, generative AI, and GraphRAG, which brings together Neptune and Gen AI and how they work better together. If you've been following previous shows where I've been hosting, we've talked about OpenSearch in the last two. One was how do you do a retail store using OpenSearch to do sort of textual searches, but also semantic searches, and how to do a vector index to do a more of a fuzzy match to be able to say, I'm looking for something like this and have it actually answer that, even though you asked a question that didn't have any of the keywords in your question in the product name. And then the next week, we talked about OpenSearch and doing backend observability to be able to track, if something goes wrong during the retail flow, isolating that. And this kind of builds on that in that now we're going to be using graph databases to understand more about how do we ask a question, get a really rich answer, different tech stack, Gen AI, vector, but going beyond vector with GraphRAG. And so we're going to start off by learning what graph databases are and how Gen AI makes graph databases easier to use, and then how graph databases makes Gen AI easier to use. This is the better together. And I'm here with Dave. Dave, can you introduce yourself?
Thanks, Jason. Yeah, so my name's Dave Beckberger. I'm a principal graph architect on the Neptune service team. And I've been working in software for 20 plus years at this point. Kind of makes me old, makes me feel old every time I say that anymore. But been working with software for a long time, kind of across all different stacks. But about the last 10 years or so, I've been working primarily in graph databases. And then for about the last 4.5, working here on the Neptune service team.
Cool. And I'm Jason Hunter. I'm a principal solution architect with DynamoDB. But just because I love Dynamo doesn't mean I don't also love graphs. And Dave's in Alaska, as you can tell by the picture behind him. That's a little map of Alaska or something.
Yeah. It's a funny map that I found online somewhere so that's Alaska. And then like over here, this is the lower 48 off in the ocean by Hawaii, because that's where they always put Alaska. So I've had people ask me like, oh, it's really warm in Alaska, right? I'm like, no, it's not near Hawaii at all. That's just where they
All right, I like that. All right, so we've got this. You're my first guest from Alaska.
Well, there's not many of us up here, so
didn't get the other guy yet. Let's start with what's a graph? What the heck is it? It's a like a stock chart, right? It goes up and to the right.
I mean, depends how you ask, but we like, at least in the graph world, we call those charts. So okay, graph is really, when it comes down to it's a data structure. It's a data structure where you deal with entities and connections between entities. So the history of graphs go way back. There's a mathematical history around it from like Euler and the 7 bridges of Königsberg. But from all practical purposes, when we are talking about graphs, we're really talking about that data structure that really is built to work with highly connected data. And it does that through what I kind of like to say of elevating relationships to as important as entities themselves. So a graph, the basic pieces of a graph are entities and relationships, or nodes and edges in graph terms. But you can kind of think about them when you're thinking about it as nouns and verbs. We use as developers, we use graphs all the time. We may not know that they're graphs, but things like linked lists, trees, these are all a graph data structure. They're all about how those things are connected. How something is connected to something else, and that connection being very, very important. When you're working with that.
Yeah. So it's just, instead of like rows and columns or keys and values, I have nodes and edges.
Yeah. You have nodes and edges representing entities and relationships between entities.
When I come go there and ask questions, tell me about how this is related to that. What's a good use case for a graph database?
I mean, kind of the probably the most canonical one is something like a social network, where you have people that are connected to other people. And in that sort of thing, those connections are really maybe the most important part. And it's probably less important who's connected, but that they are connected. So, I mean, that's kind of one use case for a graph database, but they're used in a lot of other things. Fraud is another common one, but there's also a lot of ones that you wouldn't necessarily think of as connected data problems, but when you really kind of dig into them, the types of questions you want to answer are really about the connections between it. We have a lot of our customers on the Neptune that are using the Neptune service are from like the security space. So Wiz being one of those customers, and they're use the graph. So those security customers are using the graph to do things like map your network topology or your AWS topology into that, because the types of questions you really want to answer, like, okay, if I built an insecure IAM role, that's not great. But really what I want to know is that role being used? If it's being used by what, and what does that have access to be able to answer questions like, do I have anything with an insecure IAM role? Maybe I put a wild card in the policy. Do I have anything that's using a policy with a wild card that's attached, that's being used by something that's maybe accessible to the internet? Because, having a wild card in your policy or something like that, it's not a best security practice, but having that exposed to the actual internet basically increases, in that case, like a threat vector. So, something like a security use case is common. Things like bill of materials are also common. You kind of think about that. You have you have some sort of deliverable. That deliverable is made up of pieces. Those pieces are made up of sub pieces. Those sub pieces are made up of sub pieces. And you start to take this, you can start to think of this very large tree or network of different things, different parts, pieces, how they're all connected, things like that. And that's really kind of, one way to think about what is a graph? What are the types of questions you want to answer with a graph? What are the, what are the good and bad?
Things someone asked, is this live or recorded? Well,
this is live.
It's recorded. That come on, we had to. It's funny. Yeah, I think this is funny. There's a question of a relational, like you say relational, which is very relational, and then you have graphs, which is like relational plus plus. A graph database, the focus is relationships, right? Maybe not exclusively, but you have the entities and relationships, but really relationships is what matters, right?
Well, I mean, so we can get really go deep database nerdy here if you want, but really when it comes down to like relations in a relational database are sort of implicit through the foreign keys between two tables. That's how you say this is associated with this.
Right.
In a graph database, those relationships are actually explicit data stored on disk. It's kind of the way so one of the advantages for like a graph database is something like recursive traversal. So, jumping back to our social network, relational databases are great at answering questions like find me Jason's friends, find me Dave's friends. It's a simple join, or find me like friends of friends. Then, we can all do that. But being able to actually jump in and say something like, how are Dave and Jason connected in this graph or in this social network? That's something where if you're looking from a relational perspective, it's going to have to do a lot of work because you have to write essentially a recursive traversal to do that.
Yeah.
And every time it goes to go out another, join in relational terms, it's going to have to calculate all of those relationships to be able to figure out whether it's the right one or not. In a graph, because those relationships are stored as data itself, all it has to do is kind of traverse data as opposed to calculate data. So it's very good to quickly be able to move through your your connections in order to get lanes.
All right, you mentioned Neptune. I assume Neptune is what we use to do these storing fast.
So Amazon Neptune, that's the team that I'm part of, is AWS's purpose-built managed graph database service. So it basically is a graph database itself. So a graph database, it's a type of NoSQL database that's really optimized for storing those sorts of, for storing those graph data in a way that allows it to be easily queried.
Do I use SQL to query it?
No, you don't use SQL to query. You end up there's purpose-built graph query languages. Neptune supports 3 of them. We support Sparkle for RDF style data, or Gremlin and OpenCipher for property graph data. And they're all kind of built and optimized to be able to answer those sorts of connected data questions. Like, I don't have it available here, but there's great examples you can see out there. Like, you want to answer that friends of, how Jason and Dave connected in a social network. It's this much SQL and 2 lines of graph queries because they're really optimized to answer those sorts of questions.
Here's a challenging question from the audience. Name one thing, Dave, a graph database can do that my fleet of Excel sheets located in a public Dropbox folder that powers my entire payment gateway can't. Justify your existence.
I mean, if your entire payment gateway is putting in a public Dropbox folder, I'm a little more scared in that sort of scenario. Regardless of where your data is, that sounds pretty insecure. But I mean, when you think about it just at a high level, this kind of goes back to similar to the relational database. It's being able to quickly and easily draw connections between those data. Pretty difficult to be able to do. PCI compliance is merely a suggestion. I don't think it is. Which website is that? I don't know.
Yeah, you're allowed to post URLs. People who are adding comments. One of the use cases is like people who bought this also bought this, right? So when you go to a retail site and you're looking at something, it understands the relationship. Like maybe this is an accessory for the products that you've already previously purchased. Maybe people who buy this, air filter machine also get this air filter replacement filter, things like that. And so then these things are relationships, and you model this person bought, but also this thing has an intrinsic link to, and therefore, what 5 things are you going to do that increases your sales by showing them? And I've seen graph databases used for that.
Yeah, personalized sort of recommendation sort of things. In fact, I mean, the data we're going to be demoing today, it's not personalized recommendations. It's actually built on software bill of materials. So if you kind of think of that, what is a software bill of materials? But it's, here's the package. That package is made up of libraries. Those libraries have things like licenses or references or vulnerabilities associated with them. So you start to build up this essentially, this structure that is a network of different connections between those pieces that, this library uses this library has this vulnerability. This other package uses that same library that also has that same vulnerability. So you can kind of start to see how you're building up this, this set of interconnections, which is a graph, to be able to actually, start to answer questions like, which connections between, what is the, when you come down to this sort of thing, it's like, okay, I want to be able to prioritize what vulnerabilities I'm going to be working against. So knowing how many things are using it, what packages are using it, how severe those sorts of things are, it allows you to kind of be able to get a more holistic view across those different things.
You've got a demo of this?
We do have a demo of this.
Let's see it.
Great. So yeah, I mean, what we're actually going to be starting with here is this is one way, to be able to use generative AI with graphs. Yeah, I mean, as you kind of let.
Why do I need Gen AI with graphs? Why do
you need Gen AI with graphs? Well, I mean, there's a couple of reasons, but one of the big ones was kind of one that you brought up. It doesn't, graphs don't use SQL behind the scenes. They're using those purpose-built graph query languages, and there's a limited number of people that know how to write these and know how to actually be able to do it. So, and what we're going to be showing here is a couple of different things. The first part of this demo, we're going to be going through how you can use generative AI to work with graphs better, and then flip it in the second half, as you kind of mentioned. But this is the how do I use generative AI to make it easier to work with graphs. And the way we're going to be showing here is we call it natural language querying, or being able to basically take a English question, have it converted into a graph query, have that graph query one to be able to answer that. So, I mean, here I just ran, how many vulnerabilities exist in this data? This is
213 in the world. Well, that's good.
213 in the world. Well, it's not in the world. I loaded a few S-bombs. I think I loaded 3 different S-bombs with S-bombs software bill of materials that I got off of GitHub. So okay. Don't worry. These are, we're not going to expose any 0-day vulnerabilities or anything here. These were all older versions. So, all right. These have all been fixed. But yeah, so being able to, expand the number of people, expand the amount of people that are able to actually interact with your graph data is one way that we're seeing a lot of people be very interested in using these together, because, probably I'm guessing up until, right now, you've probably never seen this. You've probably never seen OpenCipher, which is what the query language you're looking at here.
This is OpenCipher.
This is OpenCipher.
So they named it like cryptic. Cipher means like hard to understand, doesn't it?
Well, it does mean hard to understand, but so the brief history here is OpenCipher was a project by another graph database vendor known as Neo. I think they just had a little bit of a matrix thing going on. I don't know the whole.
Cypher's a character, right?
Yeah, Cypher's a character there.
All right, so what you just did is you asked a question, and it converted that as best it could. Says Bedrock here. Into an OpenCipher query, which then it ran and gave you the results, but also showed you what it did. It showed you the query. Now, this reminds me, like I saw this recently in CloudWatch, where I wanted to go digging, and it gives me an empty text box, and it says, what would you like to do? Use our custom language you've never seen before. And I was sitting there like, oh man, do I have to learn a new language right now? And there was a little button there that said, would you like help? Would you like Gen AI help? Heck yeah. I typed it and it populated, with the right syntax for the right query language in that context. And I was like, oh, sweet, hit the button and I was done. And I didn't have to learn a darn thing. So what you're offering here is the same kind of, would you like to do a query against Neptune and not learn a darn thing? Oh, yes.
Yeah,
well, maybe it's like learn iteratively. I will do natural language. You'll show me natural, show me. All right.
Yeah,
I get you.
Yeah. So, I mean, pretty much what we're looking at here is kind of the architecture of how this works. Taking, submitting a query. Basically, you submit a query. First thing it does is, in this case, we're using an integration we have with Neptune through an open source toolkit called Llama Index. You may be familiar if you work with RAG applications. It's kind of a framework for building those. And one of the things it also offers is the ability to do this natural language querying. So the way it kind of works is you submit a question to this framework. This framework then kind of works as an orchestrator between Neptune and Bedrock. And it starts that way. It goes out to your Neptune database and gets the schema, because it's going to need that schema in order to be able to understand how to take the intent of your question and the structure of your data and combine the two, which is really what we're looking to do.
All right.
So, you have that question, you have your schema from the database, and then takes those two things and sends that off to the LLM. In this case, we're using Claude v3 Sonnet hosted by Bedrock, but you could use others as well. But that's the one we're using in these sort of demos and examples. So it takes that. The LLM then goes off and does its magic. It takes that information, runs it through its reasoner and its neural network and all of the things that LLMs do, and it comes back with a converted version of that query. That query is then taken and basically executed against Neptune, and the results are returned.
So, yeah, it is exactly the CloudWatch example where I'm in a console somewhere. I'm allowed to ask any question I want, but I don't maybe know the syntax well enough, and I'm getting some help, and it can show me like, hey, is this kind of what you want to run? And you say yes or no. Get Schema is doing a lot of heavy lifting there. I think it's the value of having it integrated, in that if I couldn't go to another Gen AI over here and ask the question because it wouldn't know the schema of my data. But it makes me wonder if my schema, if I'm overly cute in my naming and manufacturing date is MD, how does it know that MD means anything?
In that sort of scenario, that's I mean, just like if I asked you how what does the MD column mean, and you have no context that it means manufacturing date, it's going to be very difficult for it to be able to actually work with that. So you'll have to do some sort of prompt engineering. You'll probably have to add it into the prompt that MD equals manufacturing date.
Or do a better schema.
or I mean, ideally you would do a better schema, but we've all seen that, and we're all guilty of doing it too, of building of building out tables that were short, or columns and tables that were short versus descriptive sort of thing. But yeah, I mean that's generally, I mean that's going to be a general limitation of all of this. Like it is, it isn't only it's only going to be able to know what it's being told. It's not going to be able to guess in a lot of ways. That's not really what it. Well, it will guess, but that's not necessarily what you want it to do. You want it to be a little more prescriptive. So you want to kind of give it.
Yeah.
You need to give it enough prompting for it to be able to be successful too.
Now you promised this was the open world version, the one where I can ask for anything, but then you kind of did a pre-baked question. So you can just type in there anything you want.
Yeah, I could. I mean, I could ask.
Oh, ordered by, all right.
I mean,
and now you're
the reason ones is because, as you can see,
if it works.
Yeah, I can't walk and chew gum at the same time, so I can't type and talk while I'm doing this, which is why I have the pre-baked ones there. But in this case, I'm doing something that's a little more complex. First one was just basically a point lookup. It's not, there's not really anything starting to get grassy about that. It's just going out and finding a point. That's kind of, every key value store can do that. In this case, we're now starting to look at some of the relationships between things. And in fact, you can start to see how these relationships are manifested in the query languages themselves. So little primer on Cypher here is Cypher is a pattern matching query language. So you're basically saying, find me something in my graph that looks like this. And it's represented, nodes are represented by basically parentheses. That's the word I'm looking for. So this C component is saying, find me a node that is of type component. So there's a thing in graphs or property graphs called labels. Labels you can sort of think of as like a categorization. So in a relational world, it kind of maps to a table name sort of idea. Just something to kind of put big buckets of things. And then the square brackets represent the edge type. So this is saying, in this case, I'm saying, find me everything where it has a component that is affected by a vulnerability. So in a property graph, edges also have direction. So you speak about them talking about them going from one place to another place. So this is sort of backwards of the way you might want to read it, because it really is a vulnerability affects a component. But it wrote it flipped. That's not a big deal. It's just, a way to start.
I'm kind of enjoying the fact that I don't have to understand anything you're saying, because you gave me a natural language query in front, and then the gibberish comes out with some less thans and hyphens and colons, and
I think they're one of the really key, underutilized aspects of this is also, it's a great way to help you start learning the language as well. Because if you ask this question, you can see how it's translated, and then you can start, it starts to help you giving, it gives you that starting location to start tweaking with the query to do what you want.
So people are asking what other languages besides this Open Cypher Neptune does?
So Neptune supports, for the RDF data model, it supports the Sparkle query language. For the property graph data model, it supports both OpenCypher, what you're seeing here, and Gremlin, Tinkerpop's Gremlin. So we kind of support the most common open standard languages out there for graph databases.
Okay. And then people are also pointing out that this seems about as risky as putting everything in a public Excel to just let end users type things and have it run against your data.
Well,
any thoughts about that, Dave?
It is. It's kind of funny. We're now adding these natural language query interfaces on top of this. We said for decades, don't expose your database to your users. Well, this is exactly what this is doing, and that's if I actually let it do this, it actually wrote the right query. That query would delete all the data out of my database. That's not something you really want to do. So if you're going to go with this kind of open world natural language querying approach, you really need to make sure you put in appropriate guardrails, because those guardrails will prevent you from doing things like that. So in this case, what I did was within Neptune, we have we call it action-based control. So you can basically set up an IAM policy that allows your user to only read data and not write or delete data, which is what I have in this case. And what you probably, that's probably like the very beginning of what you want to be able to do here. So this sort of open world is something I would want to only provide to, essentially, if I was going to give my end user the ability to access this data directly, this is when I would want to be able to use that.
This is exactly what I saw in CloudWatch logs, where I, as the admin, am allowed to pour over my logs. It provides a syntax, which maybe I don't feel like learning today. And I use Gen AI there in reality to find the logs that were in the last 15 minutes that mentioned the keyword. And it wrote that query for me. And I could only do what I could do in that console. Now here you kind of neutered it, but by the way, you missed, your name is Dave and you had a computer say, I'm afraid I can't do that. And you didn't go there.
I know I should have, opportunities for next time.
I'm afraid I can't do that, Dave. That's what should be. All right. So, to review the comments, people at this point think we're crazy. I got to say, they're like, you would never, ever. So can we save ourselves? Can we show what you would actually do if you had end users involved in this?
Yeah. So if we had end users involved that you would want to be able to do something here, you'd take a similar yet different approach. You take similar in as much as I want to be able to ask. I still want my end user to be able to ask those sorts of natural language questions and get back answers. But I don't want them to have access to be able to ask any sort of question. In most end user applications, there's really a subset of actions you want your end user to be able to take. So that's what we call, we talk about this as templated queries or knowledge graph retrieval type queries. But really what it is in the end is you're using the LLM. No, oh, it's a slightly different thing. What you're doing here is you're actually using the LLM to figure out what is the intent of the query that you're trying to be able to do. What is the intent or in what entity do they want to kind of work from? The LLM determines that, and then you use that to basically execute a parameterized templated query here that goes that, you have an SME or someone like myself that has written. Maybe they started with the open world version to figure out how to write that query and then templated it afterwards. That templated query, that parameter gets sent, gets run on your knowledge graph on, through Neptune, and then the results get returned. So in this case, kind of jumping back to our chat here, what we're looking at is like being able to answer questions like, I want to find information on this specific library. So in this case, it's actually going out. It's not doing anything special. All it's doing is basically pasting this, sending this prompt to it. That LLM knows like, here are the actions that I am allowing you to be able to do. So they're, being able to ask some other questions like, I want to also find maybe the documents and vulnerabilities associated with this library. Be able to do things like that. But I also, but this allows you to also be able to do things like, to our previous example, I want to delete all data in the database.
I'm afraid I can't do that, Dave.
I'm afraid I can't do that, Dave. This allows you to put those sorts of guardrails in place that you're able to work with on the, I should say, those guardrails in place so your end users are allowed to interact with it in a natural language manner, but with the, as the developer, I'm still able to put those guardrails in place in such a way that you're still only allowed to work with it the way that I think you should be able to work with it.
So to summarize this is what we're used to with phone trees, and that I call in and it says, what would you like to do today, Jason? And I say, add 1 million frequent flyer miles to my account. And it says, that does not map to anything you're allowed to do. What would you like to do today, Jason? Right. And I say, check the status of my flight. And they say, checking the status of your flight. Right. Because you have pre-made, blessed, trusted queries, maybe parameterized, in this case, parameterized with a component, which would be like my frequent flyer miles. But the natural language's job is to say from everything a human can express, it has to map to one of these n many pre-made things.
Yeah.
And no longer am I going to run some code that was invented by the Gen AI. Its job is to map. And the worst it would ever get wrong is that I say, show me about flight status, and it says changing your seat or something, which I'm used to with my car, actually, when I would be like, set radio station to 97.3, and it's like changing temperature to 97.3. I'm like, no, car, wrong.
No.
Wrong. So I guess we still have that risk. But now, like, I can only do things that the AI is programmed to know here, right?
Yeah. And when I've seen customers and worked with customers that are implementing these sorts of things, a lot of times what you end up with is a bit more of you end up with more of like an agentic approach where it's like, oh, did you mean that? Where you're going to have, let's say it's a chatbot, something like that.
Right.
Where you're going to, maybe as opposed to immediately trying to give you back an answer like I'm showing here, it'll ask you follow-up questions and try to narrow down exactly what you want to be able to do versus just saying, you can't do this. I mean, give me 1 million frequent flyer miles. Yeah, it's probably going to say no. But, if it's something that's similar but different, maybe it's like, do you want to be able to do this? And you can say yes or no and try to help, build that for your example. It helps build out that phone tree.
Did you say agentic?
Agentic, yes.
Agentic. Never heard that before. It's very agentic. Well, it's true. When I call up and I want to talk to a human, I always say agent. You want to talk to an agent? Yes. Right. It's exactly that thing where it didn't just toss me over. It asked for a clarification. I heard this. Is that right?
Yeah.
And I mean, it's kind of nice that they don't give me a list of 58 things I could do. They say, what do you want to do? I say it, and it maps to one of the 58, and they verify, and on I go. It's like a voice GUI, right?
I mean, that's how we do. If you were working with a human, that's what you do too. It just would be probably mapped inside the agent's brain as opposed. No, I still can't give you 1 million miles just because you asked nicely.
But this is still right. This also reminds me of kind of like a Zork or the old command line games where I can type anything I want, but the game says there's 5 actions. I can say go north, N, but like there's north, south, east, west, or kill Minotaur. Those are my choices, right?
Yeah, exactly. I mean, and that, let's be honest, for most software you're out there actually building, That's really what you want. You want to guide your users into one of a few workflows. I mean, even, thinking about game, open world versus closed world, even in, even in any of those sorts of things, there's still boundaries on what you can do and what you can't do.
That's true. All right. Now's a good time for us to mention that there is a survey. If you do the survey, you should get credits, although someone points out in the comment that sometimes the credits are expired. So we'll figure out what's going on with that. So yeah, we take that action item on it. But that I strategically timed the survey here before we hurt your brain too bad. We're now going to enter the part of the show where we hurt your brain. So please say you're enjoying the show now. Pause. And then we're going into the messy world, because everything up to now, all right, Gen AI, right? Either open world, closed world. But now we got to make it so that graphs can help do Gen AI better.
Yeah.
And I think the first step for that, this is all RAG, and people probably have heard of RAG a lot, retrieval augmented generation. The idea being that, hey, my turn, Dave. It's my show now. I don't know.
I'll sit back here and relax then.
Yeah, take a break, take a swig of water. So with RAG, the idea is that, because you're the Neptune guy, right? Neptune. Before this, Neptune never did any graph. Or RAG. Neptune never did RAG, right? But when did you start doing RAG, Dave?
I mean, the use of generative AI has really kind of fired up the desire to be able to use GraphRAG sort of applications, or really graphs in conjunction with kind of more traditional architecture. So,
yeah, I wouldn't have normally thought, a year or two ago, I wouldn't have thought that I'd be talking with you about retrieval augmented generation. The idea is that you do a prompt, and before you give the prompt to the LLM, you look at your corpus of supporting documents, which could be some sort of proprietary material, something very specific to your technical domain, and you do a fuzzy match, which is all vector-based and embeddings driven off vectors, which we've talked about before. You're going to get into some details. And you say, these things are probably relevant to the question. Let me shove those into the prompt to give the Gen AI a better clue and more targeted knowledge before it does the answer, right? Did I do that right?
Yeah, I mean, that's the way kind of RAG work today works.
And I got to say, at this point, I would not think that I'd be talking to a graph person about this task. Just sit tight, people. This is going to get fun. All right, so we've got a demo of RAG first, I guess, before we get into the GraphRAG. So
yeah, well, I mean, I think it's probably, even before we even get into that, let's maybe talk a little bit about where, we talked a little bit about the architecture there.
Okay.
Why would you actually want to use graphs with that? What sort of questions might be able to answer that? So, I mean, one of the challenges that comes across with I'm going to call it traditional RAG approach. I don't know what the right term one is. Standard RAG. Traditional RAG is what I'm going with. So traditional RAG approach, where you're using those vectors, sorts of, we're using vectors to do that, is at that point, what you're relying on is this idea of how are things similar in vector space, the vector magic space of, looking for words that are similar, sentences that are similar, maybe intents of sentences that are similar is really kind of what you want embedded in those, into your vectors. That's really what you're doing. And then when you go to run this, what you're doing is find me the things that are closest in, I'm going to call it vector space.
Yes.
So it would probably find something like that water and H2O are similar. That's vectors can do that sort of thing very well. They have those sorts of things. But if you wanted to be able to answer questions where the words may not be similar, but but the relationships between them are very strong, that's where something like a RAG style approach wouldn't be able to do that. So being able to find things like, maybe you want to find things like water, or, you want to find out if a surfboard, what you might want to purchase with a surfboard. Well, surfboards are out, similar to water. Water is similar to H2O. Maybe H2O is associated with a beach, and from a beach, you want a sun hat, something like that. Being able to look at how the connections between it are able to draw is really, what we call, kind of think of it as like, if you have vector space over here where you're looking at similarity of words, over here, you're kind of in the knowledge space of looking at similarity of how concepts are related to one And that's sort of the key part there, that when you're doing a GraphRAG, you're using similarity of words and similarity of concepts and giving both of that to the generation. I know.
So normally, let's try this. See, this is why we did the survey before the section, because this is where it gets deep. So with a normal RAG, I ask a question. Let's say I'm asking a question about Dynamo, right? And I've loaded up the developer guide and any internal guidance about Dynamo. And there's this RAG section where I understand the question and I understand the semantic representation of it in a way that I can retrieve the parts of the documentation that seem like it might be highly relevant. And I can put that text into the prompt so that now the prompt will be a little bit longer, a lot longer, possibly. I might write a sentence and now the prompt might be 100 times bigger. But that knowledge pulled from the documentation is in there. So that it's like, hey, this is probably useful for you. Instead of the foundation model, which is look at the whole internet, of which very little is DynamoDB related. It's very hyper-focused on, I'm like, this is authoritative. Try to put the good stuff in. And then with that enhanced prompt, the Gen AI is going to probably produce a better result. But you think you can do better than just plain old RAG if you understand the question, you do some magic. You're going to tell me about the magic. You do some magic, which says, I understand the semantic understanding, not as embeddings and words and tokens, but as an actual, some sort of like triplet thing, which is, I think in this example, it might be like, let's say we do pricing or something with Dynamo. And go.
Just to use your example there, if I wanted to ask a question that was something like, how do I do a put command for a DynamoDB? Something very simple. That's going to be probably one section of one page in your documentation.
Right. So RAG would work, right?
So RAG would work perfectly fine for that. Now, take that question to sort of a slightly more complex one where you're going to need to look at multiple different things of, I want to, maybe the question is, I want to do a put. How do I write a put command and with the appropriate permissions, and how much is that going to cost me? So now you're starting to connect things together that are not going to exist in one or a small subset of chunks in your documentation. Right. Because you're really starting to connect not just a single question, but concepts together. I'm taking a put in Dynamo, pricing for a put, and roles. Role, like how I set up a role permission for that.
Okay. And so there's a knowledge graph of how these things relate, which is going to be leveraged to expand out the RAG. All right. I think maybe seeing it in action. You want to show it in action?
I mean, even just to kind of give a very simple, another simple example of kind of what, just so you have the idea what the knowledge graph looks like. It's something like, as we mentioned, I'm based in Alaska. So if I wanted to find something where I needed to figure out how is Dave associated with Seattle. I've never lived in Seattle. I've traveled through the airport. That's probably the only information about that really exists out there in any sort of like document about it. But if you take that, if you had those documents, and all right, I said if you had a graph of how the concepts in those documents are there. So something like Dave works at Amazon, Jason also works at Amazon, and Amazon is headquartered in Seattle. You now can start to see that there'd be in a vector space, there'd be no relationship between Dave and Seattle, but there is in kind of that knowledge space of, because Dave works at Amazon and Amazon is headquartered in Seattle, there's basically a connection there that you might want to be able to
give us knowledge. The graph data model shows us knowledge about the world, which then we can use to be smarter about our RAG and bring in more relevant data than simple embeddings-driven RAG.
Yeah, because I mean,
how am I doing?
Yeah, I think that's a really great way to kind of think about it, because you could just expand out your KNN, but it's eventually you're going to start getting a lot of just unrelated stuff. At some point,
that's your nearest neighbors in the vector space. Like you can do a fuzzier match, but as long as it's based on just the embeddings, it's going to get pretty fuzzy really quickly. And you actually say like, no, be smarter. Right? Yeah. Be smarter about it.
It may be close in, you can sort of think of it. This is all about looking for things that are closely related, and they can be closely related. Something can be closely related in vector space, but not in knowledge space, or in knowledge space, but not in vector space. So what we're trying to do is combine these two things together to give you the things that are most related in knowledge and vector space, to give that kind of a RAG the best chance of being able to work.
I got it. All right. So this is regular RAG.
Yeah. This is just kind of regular RAG to show that this is your DynamoDB. This is your DynamoDB sort of question right there. Find me a put. Well, this is something what is an SBOM? Well, the documents that have been worked with here are SBOM documents. Like they're going to all have that answer. So this answer isn't particularly interesting.
Those look about the same.
They're pretty much exactly the same because you aren't really asking anything that's going to really require looking across connections.
Oh, right. It's just like, what's an SBOM? It's in one document. It went into the RAG. It was, oh, okay, I gotcha.
Probably in one paragraph in one document. Right. Because it's probably in every document about SBOM is, here's a standard paragraph of what it is.
Right. I don't need fancy retrieval.
Yeah, but in this case, I'm asking a much more complex question. In this case, I have a supplier. They're not providing me SBOM data in a timely manner. I need some reasoning in the related documentation to basically discuss why they need to do this. So this is that up level, more complex sort of question that really isn't going to be located in a single scenario. It's not going to be located in a single chunk of documents. And as we can see, I mean, you don't need to read through the whole thing. All you really need to do is read the first line right here.
Right.
And SBOM considered the automotive supply chain industry. Yeah, at no point did I mention that I'm in the automotive supply chain industry. This is sort of that example of the sort of challenges you can get with vector space where it's looking for related knowledge, but it's not there. And in this case, it's kind of making, the LLM is making up some sort of generated response. There's some information here, but it's pretty general, to be honest.
Right. It didn't understand well enough. So it did the nearby vector space, but it didn't realize that wasn't appropriately targeted.
Yeah. I mean,
it can do better.
The information is
on the left. Is it going to do better?
It's going to do better. So, I mean, right, in the end, there's some information here. It's pretty, I know no one's going to read it all. I can tell you from looking at it, it's pretty high level and not very specific. In this case, this was using a GraphRAG. And this is using that combination of vector space and knowledge space to be able to figure out more relevant context to be able to provide to your LLM. More comprehensive and relevant context to provide to your LLM. And in this case, you're not going to, yet again, nobody's going to probably read all of this. But what you will see is it's actually going through, and it's not just telling me some very high level things, but it's actually kind of citing who published a specific guidance and what the importance that they called out was. So it's giving you a more kind of complete and comprehensive answer to it.
All right. People are curious about the architecture here and asking, like, what do I need a vector database, vector index?
Yeah.
Does this all come out of, how does this work? So I think this might help. So we kind of saw it. I think we saw that you got a better result with the GraphRAG. So show us how. How did that work?
Yeah, well, I mean, I think there's two key parts when you're looking at any sort of RAG architecture. There's kind of two sides of the problem. There's the indexing problem, and then the retrieval problem. So how do you basically build those vector and knowledge graph spaces, and then how do you use them at query time to be able to pull information out? So kind of a standard RAG architecture. You have a bunch of document sources. Those documents are chunked up. We're not going to talk about how you chunk them because chunking strategies would be an entire show of itself on how you're able to do that. You take those documents, you process those chunks through the LLM, you create some sort of embedding, and that gets stored into some sort of vector index. Like this is probably, OpenSearch was something I think you said, we
did OpenSearch before.
Yeah, OpenSearch would be a great example, and actually one we see a lot of customers working with there. So GraphRAG indexing is pretty much the same through the first part. So you have your document sources, you chunk them, you process in the LLM, you store the embeddings of those documents into a vector index. The other part that is kind of unique is also you take those same document chunks and you extract out those key entities and relationships. And that's really where the GraphRAG part, or the graph part of GraphRAG comes in, which is building this knowledge graph from the key knowledge pieces that are located inside of those documents. So this is where you get the Dave works at Amazon would be maybe one document. Jason works at Amazon is another document. Amazon headquartered in Seattle would be coming from a third document. So you're building up this kind of connections between those different documents in your knowledge graph.
We're learning a little bit, not just having coincidental word appearances together.
Yes.
So we're going to put that knowledge into a knowledge graph that then we're going to use shortly on the retrieval side.
Exactly. Yeah. And you're adding additional context to that because, for Amazon, for example, Amazon headquartered in Seattle probably means Amazon is not a jungle. Like, those, you're adding some additional context that may or may not exist in the document chunks or in the vector representation of those document chunks.
Okay. So that's indexing. Now I've got my vector index, which can be pick your favorite. And I've got my knowledge graph and a graph database.
Yeah.
All right.
So
what now?
The flip side of this is on the retrieval side. So now you have built this vector index and this graph. What do I do with it? So standard RAG approach, you take a question. That question generates some sort of embedding. That embedding is what's used against the vector index. That vector index is doing some sort of cosine similarity or HNSW sort of, algorithm on that to figure out the K top closest.
Fancy way to quickly find similar vectors.
Yeah. Fancy way to find out that water and H2O are similar to each other.
And then it returns it and then generates the results.
Yeah.
All right.
Returns it and generates the results. The difference you have with a GraphRAG is, and what we're talking about here is kind of one way to do a GraphRAG. Like all of them have the same general patterns. Exactly what the data models look like can vary, and exactly what order things are running can vary. But in kind of the most simple example, you're basically using the same flow. You ask a question, that question generates some embeddings, and you return the top K documents. You can also then use the information from that question, the key concepts in that question, to query the knowledge graph, to be able to say things like, okay, I know that this question is about Dave. Now, from Dave, go out to their connection or to the connections and the connections of those connections and find me the other relevant information about where I might want to fetch those sort of document chunks.
It's another way to expand the view on the question. On the one, you take the question, you go find similar from your typically document corpus to find things to prompt. And this one, you're doing a knowledge graph and you're walking a graph for nearby connections to find a way to find things that are relevant to put into the prompt to make a better prompt.
Yeah. So in the first one, your prompt is going to have a bunch of documents, and your second one, your prompt is going to have documents and graph stuff.
Does it return? What does it return in step 6?
So, and this is where it varies slightly on exactly, which version of a GraphRAG you're building, because GraphRAG is it's a relatively new concept. I mean, RAG is relatively new and GraphRAG is newer than that. So there's a lot of ongoing work, but it usually comes down to either I'm returning other relevant chunks of documents. So, or I'm returning other relevant facts from the knowledge graph. So it could be the documents, it could be the chunks of the documents that the facts were pulled from, or it could be the facts themselves. So it could be, here's the document that said that Amazon was headquartered in Seattle, or it could be just the fact that Dave works at Amazon and Amazon is headquartered in Seattle. There's kind of
all right. So I can see why either one might be good. Maybe here's some text for the prompt, and also maybe here's some knowledge from the prompt that's summarized shortly. And then what in step 5? How do I do step 5? Where I have a question and I'm supposed to create a knowledge graph based on your English question. That seems like magic.
So this is where a bit of the LLM magic comes in, because when you're actually running these queries and pretty much all of the mechanisms you can do it, it's a fixed query where you're basically kind of started a node in my graph where the value is Dave and then hop out to it. So the query is much more like a closed world query in as much as it's a fixed query that you're essentially kind of giving it a parameterized start point.
Oh, okay. So I would write a set of knowledge graph queries that 5 could pull from.
Yeah, because your knowledge graph is going to usually have some sort of building structure already. The topology of it's not going to be free form. There's going to be kind of a known structure, a known schema you're working against.
Got it. So do you have a heuristic for when I should think only RAG or when I should think that a GraphRAG supplement would be beneficial to me?
So, I mean, really where it starts to really come into its own is when you have those sorts of questions that require, to go back to the documentation example, the ones that start requiring you, if you think about it from a documentation perspective, in order to answer this question, I'm going to have to go to the DynamoDB page, and then I'm going to have to click a link to go to the to go to the IAM to understand how to set up the role, and I'm going to have to click a different link in order to go to pricing in order to figure out what each request is going to cost me. Like those, from a mental model, questions that require that sort of complex, multi-connection sort of answer, or information in order to answer, are the sorts of things where RAG tends to struggle because it can't, it's only looking for things that are similar in that vector space. And the questions that require going across those connections are where you're really starting to look for things that are similar in knowledge space.
So can I think, like, if I asked a person to do this, would they be able to find me a page of reference, or would they be sending me a lot of links to put together the answer?
That's actually
More
a great way to think about it.
All right. The more likely that poor person I asked my question to is going to have to click around a lot and send me a set of links and derive some knowledge, the more likely that I should consider GraphRAG.
Yeah. And I saw the question pop up here about, do you need a separate vector store?
Right.
So right now, everything I'm running here is actually using Neptune database, and I have a separate vector store because Neptune database doesn't have a built-in vector index. But if you're using a different, we have there's two parts to Amazon Neptune. There is Neptune database, which is an online transactional serverless graph database. And then there's Neptune Analytics, which is an in-memory database analytics engine. If you're using Neptune Analytics, it actually does have a vector index built into it. So you could do this all in one database under the covers. But we see customers kind of go both ways, either using Neptune Analytics with the built-in vector store, or using like the serverless option for Neptune with like serverless open, Amazon OpenSearch serverless to be able to kind of have a pure serverless GraphRAG experience.
All right, cool. So if I want to get deeper into this, what should I do? Do you have a blog? Is this code available?
So this code is, we have an Amazon Neptune's generative AI samples repo up on GitHub where this code will be. It'll be up there hopefully by tomorrow. It's in a branch up there right now. I just haven't had a chance to kind of get it merged into the main line. But there's also other examples up there. So like the natural language querying ones, there's example notebooks up there today showing how you can do that. There's a few blogs on the dev.community or community.dev site for AWS, kind of walking through how you can use Llama Index to do natural language querying and knowledge graph retrieval, the closed world version of natural language querying. Keep your eye out there. There'll be coming out here very shortly about how to do this GraphRAG part of this as well. It's one that I'm working on. If you are interested in Amazon Neptune, we have a developer resource page. Would probably be the place I would have you go there to take a look, because that starts to show you not just the GraphRAG part of it, but the other sorts of things that you can do with graph databases, the knowledge, the other sorts of use cases people have, as well as a bunch of samples, examples, videos, things of that nature to be able to kind of get started.
All right, so let's get a link out there in the comments for people where this will be hosted soon.
So the generative AI repo is up. This specific example that you're seeing here will be up in the next day or two.
All right, cool. So if you're watching recorded, then you can get it. And if not, then pay attention. I guess just follow if you go there, that GitHub link.
Yeah, if you go there today, you can find you can get started with the notebooks on natural language querying. That's already there. There's also, if you wanted to just take a look at Llama Index, there are over on the Llama Index, which is llamaindex.ai. There's sites, there's examples inside their documentation of how to do all of these different kind of querying as well as GraphRAG functionality.
How difficult is this to put together with Llama Index, like on a 1 to 5?
I mean, on a 1 to 5, I would actually say using Llama Index is probably about a 2 or 3. There's a little bit of, probably bait and tackling you have to do as far as like kind of setting up your infrastructure, setting up your connections into Bedrock, things like that. But once you have that, it's very easy to kind of try out the different versions of RAG, GraphRAG, all of those different things. So, because the way Llama Index is sort of built, it's kind of built with a pluggable architecture. So it's sort of like, here's my data store, here's my corpus of documents. I can run this corpus of documents across multiple different versions. I mean, for example, like there was really only very few lines of code that I had to write to get to have a RAG and a GraphRAG running on the same data.
How hard is it to understand what a GraphRAG is on 1 to 5, would you say? What we just did. I feel like it's a 4 to understand GraphRAG and the tool to implement GraphRAG. Rarely is any piece of technology harder to understand conceptually and easier to implement. What do you think? Am I right?
I mean, I think I think that partially also depends on where you're coming from. I think if you're I think if you're very deep into RAG, understanding the difference between vector and knowledge space is probably a bit of a shift in the thought process. But if you're coming if you're coming brand new into it, whether you're working in we're going to call it magic vector space or in this knowledge space or in both is probably a little less. And in a lot of ways, one of the key things that we didn't really touch on here, but that graphs also provide is some explainability into why these things are connected. Because I can look at Dave, Amazon, Seattle, and that makes sense to me. There's no way I can look at a vector and understand why these two things are similar. I can look at the text and probably figure it out. But
right. Yeah, that's true. If someone says, why did this get chosen? It's approachable to understand.
Yeah.
With GraphRAG.
Yeah, that's one of those things where it really provides a level of explainability. It's not perfect explainability because you're still feeding this to an LLM and the LLM is going to do what the LLMs do. It's not going to necessarily give you an explainability of the output, but it gives you explainability of the input.
Got it. Makes sense. Yeah. So key value is what anything beyond the key value query.
Well, I mean,
as a Dynamo person.
Yeah, but I mean, the way I look at it is every database at some level is a key value store with a useful abstractions built on top of it.
No argument from me. Everything should be key value, Dave.
Oh. Don't know I agree with that.
So long as there's with a sufficient amount of abstraction above.
With a sufficient amount of abstraction. I mean, we've seen customers try to build graph databases using Dynamo. It just requires them to do a lot of work.
Yeah, sure. Because you'd just be continuously pulling from Dynamo. But I can see that at the end of the day, isn't everything just key value? All right. If there's any final questions, ask. Otherwise, do you even read chats? No. Gabrielle, we don't. Yeah, we do. So there are a lot of great questions this time. So I appreciate that. And we'll call it. Now, next week, I asked, can I talk about what's coming next week? And the answer is, I can only tell you that it is about a new release. It's a new launch, but I can't tell you what it is. So that should be fun. Same time next week, right here. It's going to be a launch release show coming up. But thank you so much, Dave. That was a lot of fun.
No, thanks for having me on. And hopefully we didn't make the second half too challenging for people. Hopefully we're kind of able to explain the concepts of how this works together.
I think so. And yeah, if you waited to do the survey, please fill it out now, even at the end, now that we hurt your head a little bit, or at least just hurt my head. I don't do graphs all day. All right. Thank you. Goodbye, everybody.
Thank you.